Welcome to episode 9, the final episode of our series on Linux namespaces. This series is for anyone who wants to know what Linux namespaces are and how to make your own Linux containers, similar to Docker containers. This series is meant for junior software developers with basic programming skills. Our goal is to learn the basics of isolating Linux resources because it forms the backbone to container technologies like Docker and Kubernetes. We've come a long way since episode 1 of this 9-episode series. Let's do a quick recap. In episode 1, we learned about computer fundamentals. In episode 2, we learned about file systems, mounts, and the mount namespace. In episode 3, we learned about computer processes, process IDs, and the PID namespace. In episode 4, we learned about computer networks, network interfaces, virtual network devices, IP tables, and the network namespace. In episode 5, we learned about inter-process communication, message queues, shared memory segments, semaphores, and the IPC namespace. In episode 6, we learned about the Unix timesharing, system identifiers, hostname, domain name, and the UTS namespace. In episode 7, we learned about control groups, how to limit resources used by processes, and the control groups namespace. In episode 8, we learned about user privileges, Linux capabilities, and the user namespace. And for people who already know how to use Docker and Kubernetes, we saw how to troubleshoot low-level issues in Docker and Kubernetes using these tools that we've learned in each episode. Now we are into our final episode. We will take everything we learned in these past 8 episodes and build our own basic Linux container. Everything we do in this episode is just a summary of all these previous 8 episodes, so you're not going to learn anything new here. You're just seeing everything come together. So let's get started. I've documented our experiment on this web page here. All we will do in this episode is build a few Linux containers and connect them to the internet. We're going to need a Linux server, and I already have a virtual machine set up with a cloud provider, and I have Ubuntu 22.04 installed on it. We will need 3 terminal windows, which I have here. The first terminal window, I'm going to log in with the root user, which I have right here. For the other 2 terminal windows, they're going to be unprivileged users. And I'm going to create a container for each of these terminal windows. But I don't have the unprivileged user made yet, so I am going to make that right now. So let's say add user, user1, and I'll keep the password something easy to remember. It will be ABCD1234, ABCD1234, and I will just accept the defaults here. Yes. And let's add the second user. Add user, user2, ABCD1234, ABCD1234. And I will just accept the defaults. Great. Now let's actually log into the server with these 2 new users. And to do that, I need to remember the public IP address of this machine. It's the 172.235.144.163. So let's copy that. And let's go to our second terminal window and let's log in at this IP address, ABCD1234. All right. And same thing with the second or the third terminal window, but we'll do it with user2, ABCD1234. All right, that seemed to have worked. Okay, so we're ready to really begin our experiment. From the terminal 1 where we have the root user, we're going to set up the bridge interface. And later on when we create the containers will have virtual Ethernet devices that connect to this bridge interface for the internet access. Now these steps over here are just straight out of episode 4, where we learned about the network namespace. We learned about network interfaces, how to set up bridges, IP tables, IP forwarding, network address translations, and such. So if you need to remind yourself what all that stuff is about, just watch episode 4 again. So we'll go ahead and create this bridge interface. And I'll just paste it like this. And just like in episode 4, we will need a root user to configure all these network resources on the host machine. Let's assign an IP address to this bridge interface. Let's turn on this bridge interface. Let's have the IP tables do the IP forwarding. And copy. We also have to turn on at the kernel level and also do the network address translation. All right, so there is one more thing I forgot to mention in episode 4, and that is if you are creating these containers on a Linux machine in an office network behind an office router, the router might need additional network address translation rules to allow your containers to reach the internet. And that can get a little bit more involved, and it's really different for every network. So for now, I will avoid those challenges by doing this experiment in a virtual machine in a cloud environment, because cloud providers usually have more permissive access to the internet. All right, so now that the bridge interface is set up, we can start creating our first container. So let's go to terminal 2. So that can be this window over here. And what we're going to do is we're going to download a copy of the Alpine Linux distribution. So let's do that. And just like in episode 2, where we learned about the mount namespace and file systems, what we're going to do again is isolate a new file system and have it work with the Alpine Linux distribution. So this is just straight out of episode 2. I'm going to make a new directory called Alpine. Oh, my keyboard's frozen. Hold on. Oh, there we go. And let's unzip the contents of our Alpine distribution into the Alpine directory. Whoops. Let's copy just this line and not those extra comments. There we go. So let's take a look. Great, everything is there. And next we can move on. What we're going to do is create the user namespace. And if you remember from episode 8, the user namespace is the only namespace that doesn't require escalated privileges to create. And by passing in the -r flag, we are going to automatically map user1 from this parent namespace into the root user of the child namespace. This way, this unprivileged user, so this unprivileged user1 user, will become a privileged user inside the child namespace. Again, if you don't remember the advantages or the reasons why we're doing this for the user namespace, just rewatch episode 8. Okay, so let's run this command. And actually, before I run this command, let me just type ID. So with ID, you can see that we are currently user 1000, which is an unprivileged user. And now let's create the user namespace. And now if I type ID, you can see that we've become root. And this root user is not the same root user as the host machine's root user. And just watch episode 8 again, and you'll learn how to verify and confirm this through the UID maps and the GID maps. So now that we are the root user inside this child namespace, it means we have the privileges to create every other namespace. And what we'll do is we'll start by creating the UTS namespace, the Unix time sharing namespace. That's because the UTS namespace allows for host name isolation. And we want to change the host name of this container to something that will be different from the eventual container 2. That way we can differentiate container 1 from container 2. All right? So if I type host name, you can see right now it says localhost. But if I change it to, let's say, container 1, and I type host name again, and now you can see it's been changed. If I want it to change in the prompt here as well, all I have to do is just run the bin bash command again, or start a new bash instance. That will definitely update this terminal prompt here. But I don't need to do that because I'm about to create more namespaces. And one more note is that if you really want more details on the UTS namespace, I believe that was episode, let me just check my notes for a moment. So if you want more information about the UTS namespace, just watch episode 6, where we go into full details about that. And now we can create a new namespace that has isolation for all remaining Linux resources. We will run the unshare command and pass in the PID fork and mount proc flags for PID isolation, just like we learned in episode 3. We will pass in the net flag for network isolation, just like we learned in episode 4. We will pass in the IPC flag for inter-process communication isolation, just like we learned in episode 5. And we will pass in the cgroup flag for cgroup isolation, just like we learned in episode 7. So let's go ahead and run this. And because we started a new bash instance in this new child namespace, you can see that it has grabbed the latest hostname from our previous command. Now, just to confirm that all these isolations have occurred, what we can do is, if I type psauxf to look at all our processes, you can see that there's only 2 processes inside this child namespace, which confirms that PID isolation has occurred, because if I look in my parent namespace with the root user, you can see that there's a lot more processes in the parent namespace. Even from this user's perspective in the parent namespace, let me just make this a bit bigger. You can see that there's a lot more processes. So what we've just seen is that we have process ID isolation already taking effect inside this child namespace. Let me just clear the screen to make things a little bit less busy. The other thing we can confirm is network resource isolation. If I were to clear the screen for a moment, and if I were to type IPA, you can see that there's only one network interface, the loopback interface. But from the parent namespace, there are multiple network interfaces here. We can also confirm the isolation of inter-process communication facilities. If I were to clear the screen for a moment and type IPCS, you can see that there are no message queue, shared memory segments, or semaphores inside the child namespace. And right now in the parent namespace, there are also none here. But if I were to create a semaphore, IPCMK and -s of length 1, IPCS, you can see that it's been created in the child namespace. It doesn't exist in the parent namespace. And if in the parent namespace, I go ahead and create IPCMK-Q for a message queue, IPCS, there is a message queue in the parent namespace, but there are none inside the child namespace. So we've just confirmed that we have inter-process communication isolation. And let's also confirm the last thing, cgroups. So if I were to type cat proc cgroup, you can see that there's no cgroup information in here either. So at this point, let's finish setting up our container. Let's take a look at this. Let's go ahead and create our virtual Ethernet pair so that we can start gaining internet access from within this container. But to do that, we're going to need to know the process ID, and because we already have process ID isolation, we can only see the process ID from the perspective of the child namespace, but we need the process ID from the parent namespace. So we're going to do what we did in episode 3. We're going to cheat. What we can do is run the sleep command or maybe just run the tail command. It might be a little bit easier. And I'll just type the word pizza. And the tail command will just run forever. And what I'm going to do now is I'm going to come back to the parent namespace with a root user, type psauxf, and just look for pizza. All right, so this is in the foreground, but it's really the bin bash command that we want to find. So 1132 is what we want. I'm going to copy this, and we're going to set up the virtual Ethernet pair exactly like we did it in episode 4. So let's shrink this window a little bit so I can see things side by side. Oh, and I might need to paste, let me just paste the number to see. Okay, 1132. Okay, so let's go ahead and go IP link, add VETH0, type VETH, pair name, CETH0. Okay, we've created the virtual Ethernet pair. Yep, C and the V. Okay, now IP link set CETH0, send it over to the network namespace. And here's where we paste in our process ID for the child namespace, ns net. And with that, if I do Control C or Control Z to break out of here, IPA, I can see that the other end of the virtual Ethernet pair has been submitted in here. But let's finish configuring things from the parent. Oh, and right, the CETH is gone from here and visible in here. Okay, so let's turn on one end of our virtual Ethernet pair. Let's hook up our virtual Ethernet, the VETH0 to our bridge interface. And that should be it in terms of networking from the parent namespace. We will finish configuring things from the child namespace in a moment. The other thing I want to do is set a C group rule to prevent this or to limit the CPU usage of this container to only 50% of a single CPU core. So just like in episode 7, where we learned about C groups and child C groups, we're going to follow those exact same steps here. So let me do this. Let's create the child C group over here. C group container CPU. Great. So you can tell that we're using version 2 because C group version 2 automatically mounted these files for us. And let's set to 50%. So let me copy this. 50,000 microseconds out of 100,000 microseconds is 50%. Okay, so we didn't encounter this error in episode 7, but we're encountering it here. Let me just do some troubleshooting. Oh, I wrote a note here. Okay, I think I know why. It's because this file doesn't actually exist yet. Let's copy ls. Does it exist? It does not exist. And it doesn't exist because it hasn't been enabled for this particular version of Ubuntu. Let's just take a look at this file. Right, so we can control memory and we can impose limits on memory and processes, but for this particular Ubuntu instance on this cloud provider, they have not enabled CPU. Yeah, they haven't enabled the CPU, so I'm going to enable it. And now, if I were to take a look, I think CPU max should appear now. Oops, let me copy this. Copy, paste. Great, the file exists. And now I think we can write our rule. 50,000 microseconds out of 100,000 microseconds. Great, it's there. And I am going to add the process ID, echo, what was the ID? We may have to take a look again. I think it was the 11. Oh, my terminal buffer is out. So let's do this again. I'm going to type sleep 20 seconds, and PSAUXF. We're looking for 20 seconds. Okay, so that's this one here, 11:32. So echo, let's add this process ID to our C group rule. Sudo t sys fs C group container C group dot procs. All right, so we'll test all this out later. We've done what we needed to do from the parent namespace. Now let's finish configuring container 1 from the child namespace. We are going to turn on the loopback interface. Let's turn on the other end of our virtual Ethernet pair. Let's assign an IP address to it. And let's hook onto the bridge, or to route over to this IP address, which will eventually pass over to our bridge. And I believe, just like that, we should be able to ping the internet. So I'm gonna do a quick test. Ping 8.8.8.8. This is an IP address that Google, I think it belongs to Google. Yep, so that is good. We're getting a signal from Google. And let's actually just do a quick check. IPA and TCP dump on the BR0 interface. Okay, so no response, but the moment I start pinging, there we go. And if I stop, go, stop. Okay, great. So this is working. So everything is exactly as we did it in episode 4 on the network namespace episode. So if you really want to understand all the details of what we've discussed here, it's a 90-minute lecture and tutorial. Okay, so let's clear and clear. Now let's complete the file system isolation. Let's actually use our Alpine distribution. And if I look in here, I've got the Alpine directory, but we need to do the bind mount just as we explained in episode 2. Yeah, episode 2. Now let's go in here and let's create the root file system so that there is a way to get back out over here, but we'll close the door later. Okay, let's pivot the root and then we unmount. Okay, remember this part here is a little bit tricky, so just rewatch episode 2 on why we're doing all this. Okay, so let's go back to home directory and oh, there's no ls command. Okay, that's fine. Let's just say echo stuff test dot, or let's say container 1.txt. And if we go over here, if I go to home user 1, whoops. And if I look in the Alpine directory, yeah, we can see the container 1 file. Yep, so we can see that. And there's no way for this container, or it's much more difficult for this container to access the root file system. All right, so in fact, let's try this container. I want to print it straight to the root. Okay, and if I do an ls here, yes, it appears here as opposed to appearing at the top level of this host machine's file system. So we've got our file system isolation and mount isolation in effect. So we've done this test, we've done this test, and oh, let's actually make sure that our, if I run the yes command, it's just going to print yes forever and push the CPU to its maximum or maximum allowed, dev null. So this is running for quite a while, but if I type the top command, I should see that the container is limited to 50% usage. Yep. So we've limited this container to the container 1 to 50% usage of a single CPU core. I'll just press Control C or Control Z to break out of it. Okay, so now that we've got container 1 set up, we just repeat all the same steps, but for container 2. So let me go over here and scrolling down. Let's make the Alpine 2 direct, or we need to download Alpine. I don't think I have it here. Correct, I don't have it here, and I forgot to write down the steps, so I'll just grab that from up here. Let's download Alpine 2. Okay, and same thing, let us make the Alpine 2 directory. And let's unzip things. Z Alpine, and let's put it into the Alpine 2 directory. Okay, and let's now go into the directory. Okay, I can ignore these steps. It looks like I was doing this assuming it's the same user, where container 2 and container 1 were using the same user. This time we're actually using 2 different users, so I don't have to delete things that aren't actually there. Let's create the user namespace. Let's create the UTS namespace. Host name container 2. And let's create all the remaining namespaces. Let's do a sleep 25 or 34, and let's look for that ID here. Oops. Which is this one over here, because we're going to need that for setting up our network. Controls, or let's start from here. IP link add VETH1. We've already used VETH0, so we can't have a naming collision. Peer name CETH1. IP link set CETH1 net NS proc. Let's paste this here. NS net IP link set VETH1 up. IP link set VETH1 master BR0. And let's also add container 2 to our 50% CPU usage C group rule. And I will go echo 1372 over to the C group, the child C group that we made. All right, and let's go into our container and finish setting things up. IP link set LO up. IP link set CETH1 up. IP ADDR add, and let's pick this private IP address. Let's set the route so that we can access the bridge. And let's use our new Alpine distribution. Oops. Let's see what we've got here. Oh, I should do it from here. Okay, and now we go into Alpine 2. Let's make our root file system just so we have the ability to do the pivot root. And then we'll close the door. And now if I go back up here, if I hit echo container 2 or container 2, and I want to put it as far up the file system tree as possible. I'll say test2.txt. And although it exists here, I should not be able to find it at this hierarchy tree or this file system tree, but it will appear under Alpine 2 right here, cat test2. All right, and let's just test the internet. Ping 8.8.8.8. That looks good. And I can probably ping the other container as well, which was, what was the IP address again? Oh, there is no IP address mentioned here, but I do remember it is ping 172.16.221. So this would be 220. We set that one to 220. All right, and if I do a TCP dump -I CETH1. Oh, right. Alpine doesn't have this, but we can monitor it from here. PA. So we can go, this container is using VETH0. So if I do TCP dump -I VETH0, oops. All right, that looks good. I'm going to press stop. Go, stop, go. Great. So the containers have access to the internet and they have access to each other. Any other tests? Oh, let's test the C group rule. Yes. Just throw all contents to dev null so that it doesn't spew our screen with the letter Y. Oh, okay. And top. All right, container 2 is subject to the 50% rule as well. In fact, let's do this for fun. Yes, dev null. All right. Okay, so that is a summary of everything we've learned in the past 5 or 6 hours in the first 7 episodes or 8 episodes. Hopefully you found it useful. Now you understand how containers are made, or at least the fundamentals of it. I will be producing a new series on Docker and Kubernetes shortly. They're probably going to be just live streams or live workshops. And hopefully with the knowledge that you've gained here from learning about Linux namespaces and Linux containers, you'll be able to understand how Docker and Kubernetes actually works behind the scenes.